Parva Naturalia by Aristotle, translated by William Alexander Hammond. On Sensation and the Sensible. Chapter 1. Now that we have treated of the soul in its essential nature, and of the faculties that belong to it, part by part, our next duty is to investigate the subject of living creatures and everything that has life, to determine what functions are specific and what functions are general. Let us then take what has already been said touching the soul for our basis, and as we proceed to the remaining inquiries, let what is first by nature be first in our discussion. The most important vital phenomena, whether one regards the specific or general attributes of animals, are those which are the joint concern of soul and body, such as sensation, memory, anger, desire, and impulse in general, and, one may add, pleasure and pain. These are experienced by almost all animals. In addition to these, however, there are other attributes which are common to all animals that share in life, and others still that belong only to certain animals. The most important of the former class may be enumerated in 4 pairs, viz., sleeping and waking, youth and old age, inspiration and expiration, life and death. We must study the nature of each of these phenomena and the causes of its occurrence. The investigation, too, of the ultimate principles of health and disease is the province of the naturalist, for neither health nor disease can apply to creatures when deprived of life. And so it happens, as I think, that most natural philosophers and those physicians who have a more philosophical understanding of their science conclude in the one case with the investigation of medicine, and in the other begin their practice with deductions from the laws of nature and their application to medicine. The above-mentioned phenomena are evidently the common property of soul and body, for they are all conjoined with sensation, or are mediated by it. Some of them are modifications of sensation, or persistent conditions of it. Others are protective or preservative of sensation, while others still are destructive and negative. That sensation is mediated by the body to the soul is plain, both with and without the use of rational proof. However, regarding the essential nature of sense perception and the reason why animals are endowed with it, we have already stated our views in the treatise on the soul. Every animal, insofar as it is a living creature, must have sensation, for it is in terms of this that we distinguish between animal and non-animal. Touch and taste must belong to all animals individually. Touch for reasons given in the treatise on the soul, and taste on account of food. For it is by taste that animals discriminate between agreeable and disagreeable in foods, and so reject the one and take the other. In a word, flavour is an affection that belongs to the nutritive soul. Sensations that are excited by external objects, such as smell, hearing, and vision, are found in animals capable of locomotion, and are given to all of them for the sake of their preservation, in order that they may scent their food and pursue it, and flee from what is harmful and destructive. In the case of animals endowed with intelligence, they are given for the sake of higher well-being, for these sense perceptions convey to us various distinctions, out of which the knowledge of intellectual and moral concepts is built up. Amongst the senses, vision is the most important, both in itself and for the necessities of life. On the other hand, for the uses of reason, and accidentally, hearing is the most important. The power of vision informs us of many and various distinctions, because all bodies are suffused with colour, so that by means of this sense, more than by any other, we perceive the common properties of objects. By common properties, I mean form, magnitude, motion, number. Hearing, on the other hand, informs us merely of distinctions in sound, and in some instances of distinctions in articulate voice. Indirectly, however, hearing contributes the greatest share to our intellectual life, for it is the spoken and heard word that is the source of knowledge, and hearing is the source not in itself, but accidentally. Language is composed of words, and every word is a symbol. This explains the fact that in cases where men are deprived of one or the other of these senses from birth, the blind are more intelligent than the deaf and dumb. Chapter 2. We have already treated of the function of the several special senses. Writers nowadays attempt to correlate the senses with the physical elements as found in the bodily members in which the sense organs have their natural development. With the fifth sense, they are hard-pressed, not finding it easy to pair 5 senses with 4 elements. All of them agree in regarding vision as connected with fire, on account of a certain phenomenon whose nature they misunderstand, viz., when the eye is pressed and moved, it seems to scintillate. But this takes place in the dark, or when the eyelids are shut, in which case darkness is produced. And there is also another difficulty here. For if it is impossible for a perceiving and seeing subject to be unconscious of a seen object, then the eye must necessarily see itself. Why, then, does this not take place when the eye is at rest? The explanation of this phenomenon, as well as the solution of the entire difficulty and of the apparent fact that vision is fire, is to be found in the following considerations. It is the nature of smooth surfaces to shine in the darkness, although they produce no light. Now, we observe that the dark central portion of the eye has a smooth surface. This becomes apparent when the eye is moved, because the single organ is thereby made double, an effect which is produced by the rapidity of the motion. In this way, the seeing organ and the seen object appear to be different. For the same reason also, this effect fails to be produced when the motion is not rapid and does not take place in the dark. For it is in a medium of darkness that a smooth surface naturally shines, as we see in the case of the heads of certain fishes, and in the juice of the cuttlefish. The consequence is that when the eye is moved slowly, the seeing organ and seen object do not appear to be at once unitary and dual. When, on the other hand, the movement is rapid, the eye sees itself as in the reflection of a mirror. Now, if vision were fire, as Empedocles declares, and as we read in the Timaeus, and if seeing resulted from the passage of light out of the eye, as from a lamp, the question arises, why is it that we do not see in the dark also? To say, as the Timaeus does, that the light when it passes out from the eye is extinguished in the darkness, is a totally empty assertion. For what is meant by an extinction of light? The warm and the dry, it is true, are nullified by the moist and the cold, as one sees in the case of a coal fire or a flame, but neither of these has anything to do with light. If, however, they are attributes of light, but are concealed from us owing to their subtle presence, then light ought to be extinguished in the day during rain, and darkness should increase in frosty weather. Flame and ignited bodies are so affected, but nothing of the sort takes place in the case of light. Empedocles appears to hold the view that vision results from the eye's radiating light, as we said before. His own words, at any rate, are as follows. Quote, as a man taking thought for his journey a lantern prepares, whose flame flashes light through the blustering night, as he passes, and shutters he fastens, defence from winds, to scatter the breath of the blowing blasts, while the light pierces through by its fineness, and gleams over the threshold unfailing. So of old, fire elemental was fixed in membranes, and suffused the round pupil, held in thin tissues, a check to the water, while the fire pierces through by its fineness. Close quote. Sometimes he gives the above explanation of vision, and at other times he explains it by means of emanations from visible objects. Democritus says that vision is due to water, and in this he is right, but he is wrong in thinking that it consists in reflection, for reflection is produced because the eye is a smooth surface. Vision, however, does not take place in this smooth surface, but in the seeing subject. Now, the condition to which he refers is only a reflection of light. He has, however, as I think, no clear idea whatever concerning the general nature of images and reflection. It is also strange that it never occurs to him to raise the question why it is that the eye alone sees, while no other object in which images are reflected has vision. His statement that vision partakes of the nature of water is true, but vision is not due to the fact that the eye is water, but to the fact that it is transparent, which characteristic it has also in common with the air. Water, however, is easier to fix and is thicker than air, and it is for this reason that the eye and its pupil are composed of water. This can be proved also from actual facts. When the eyes are destroyed, water is seen to flow out of them, and even in their quite embryonic stage, the eyes are exceedingly limpid and brilliant. Further, the white of the eye in sanguineous animals is fat and oily, which serves the purpose of keeping the humid element from congealing. Consequently, the eye can resist cold better than any other organ of the body. No one ever experienced the sensation of cold in the interior of the eye. The eyes of bloodless animals are covered with a hard skin, which furnishes protection. The theory is altogether irrational which makes vision consist, as some hold, in a sort of radiation, and regards this radiation of something from the eye as extending to the stars, or as extending to some point, and there effecting a combination with the object. It would be better to assume that this combination of the eye with its object were in the eye's original nature. But even this is nonsense. For what is one to understand by this combination of light with light? Or how is such a thing to take place? For nothing combines in a haphazard way with anything else. Further, how can the internal light combine with an external one? For between them is the intervening membrane. Regarding the fact that there is no vision without light, we have spoken elsewhere. But whether the intervening medium between the visible object and the eye is light or air, it is in any case the motion through this medium that produces sight. And it is reasonable to regard the interior of the eye as composed of water, for water is diaphanous, and as nothing external is seen without light, the same thing applies to the internal. The internal also must, therefore, be diaphanous. Since this diaphanous is not air, it must be water, for the soul or the perceptive power of the soul is not found on the eye's surface, but evidently within. Consequently, the eye's interior must be diaphanous and sensitive to light, and this we can see empirically, for cases have happened in war where persons have received such a blow across the temples that the ocular conduits were severed, and darkness seemed to ensue, just as when a lamp is put out, and this is due to the fact that the diaphanous, i.e. the pupil as we call it, was cut off, as in the snuffing of a lamp. If, therefore, this takes place in some such way as we describe, it is evidently necessary to render an explanation of this kind, and to correlate each sense organ with one of the elements, viz. The seeing power of the eye we must derive from water, the sense for sound from the air, and smell we must associate with fire. For the organ of smell is potentially what smell itself is actually. The sensible object stimulates the sensation into actuality, and consequently the latter must have an antecedent potential existence. Smell is a smoke-like exhalation, and this is derived from fire. It is for this reason, too, that the organ of smell is especially assigned to the environment of the brain, for the material substrate of cold is potentially warm, and the same explanation holds good for the development of the eye. It is formed from a part of the brain, for the brain is the moistest and coolest member of the body. The organ of touch is derived from the element earth, and taste is a form of touch. Consequently, the organs of these two senses, taste and touch, are found to conduct towards the heart. The heart occupies a counterposition to the brain and is the warmest member of the body. Regarding the sense organs of the body, let the above determination suffice. End of chapter 2. Recording in memory of Mitchell Edwards. Chapter 3. In the treatise on the soul, I have given a general account of the objects of sense in their application to the several sense organs, such as colour, sound, smell, flavour, and the tangible. I have explained their function and their activity, organ by organ. But we must also determine what each of these things is apart from the organ, e.g., we must ask, what is colour? What is sound? What is smell? What is flavour? We must likewise inquire regarding the tactual, and we must begin with colour. Everything has a twofold significance, viz., that of actuality and potentiality. It has been explained in the treatise on the soul in what way actual colour and actual sound coincide with and differ from the actual sensations of seeing and hearing. We must now explain what each of these sensible objects must be in order to produce sensation and its activity. We have already said in the above-named treatise regarding light that it is the colour of a diaphanous medium accidentally produced. For when anything fire-like is found in the diaphanous, its presence constitutes light, and its absence signifies darkness. What we understand by diaphanous is not a property peculiar to air, or water, or to any other so-called body, but it is a certain natural constitution and power common to both these bodies, and found also in certain others in greater or less degree, but which has no independent and separate existence. And furthermore, as there must be a limiting surface in bodies, so here also. Light is found in an indeterminate diaphanous. It is also evident that the diaphanous in bodies must have a surface, and that this surface is colour is plain from observed facts. For colour is found either in the boundary, or it is itself the boundary. It is for this reason that the Pythagoreans characterized the visible superficies as colour. Colour indeed is given in the boundary properties of body, although it does not itself constitute that boundary. On the contrary, one must suppose that the same colour quality which is observed on the exterior applies also to the interior. Both air and water are seen to be coloured, for even their shimmer is colour. In these cases, however, air and the sea, because of their unfixed character, do not have the same colour when viewed near at hand and from a distance. In solid bodies, on the other hand, the appearance of the colour is fixed, unless the surrounding medium makes it shift. It is evident, therefore, that the principle which is sensitive to colour is, in both the former and the latter instances, the same. The diaphanous, then, in so far as it is found in bodies, and it is found more or less in them all, causes them to be saturated with colour. Inasmuch as colour is found in the boundary of bodies, it would also be found in the boundary of the diaphanous substance. Consequently, colour might be defined as the boundary of the diaphanous in a definite body. Colour attaches also to diaphanous bodies themselves, such as water and other similar elements, and it is also found in all such bodies as have a surface colour which is peculiar to the body itself. There is then, on the one hand, the possibility that the positive principle which in the air produces light should also be contained in the diaphanous. On the other hand, it is possible that this should not be the case, but that the condition then should be one of privation. As in the case of air, we have the two phenomena, light and darkness, so in bodies we have the two qualities, white and black. Regarding the other colours, we must now decide, after analysis, in how many ways they can be produced. For black and white may be so juxtaposed that each of the two, on account of its minuteness, when taken alone, will be invisible, while the combination of the two will be visible. The latter cannot be seen either as white or black, but inasmuch as it must have some colour, and it can be neither of these two, it must be a mixed colour, and different in kind from the others. It is then a possible supposition that there are several colours besides white and black, but their manifoldness is due to proportion. This proportion can be expressed by the relation of 3:2, or of 3:4. Or colours can be related to each other in terms of other numbers, and some may not be expressible at all in terms of any proportion, but in terms of some incommensurable plus and minus. The same thing applies also to harmony of tones. Those colours which are expressed by harmonious numbers, as is also true of tone harmonies, appear to be the most pleasing, such as sea purple, crimson, and a few others like them. They are few for the same reason that harmonious tones are few. The other colours are not numerically expressible. Or is it true that all colours are numerically expressible, although some colours depend upon a regular order, while others depend upon an irregular order, and the latter have this character when they are not pure? This is one explanation of the genesis of colours. Another explanation is that they shine through one another, as we see sometimes in the works of artists when they superadd a colour on a background of a different colour, e.g. when they wish to produce the effect of an object seen in the water or in the air. So it is also with the sun, which in its own nature appears white, but red when seen through mist and smoke. And many other colours will be produced in the same way as above described. That is to say, a certain proportion might be supposed to exist between the colours on the superficies and the colours in the depths, and others again may not be expressible in terms of proportion at all. It is therefore absurd to say with the ancients that colours are effluxes, and for this reason are visible. For in their opinion it is absolutely necessary that sensation be effected through contact, and it is consequently better to say at once that the medium of sensation is set in motion by the sensible object, and that in this way sensation is produced by contact and not by effluxes. In the case of juxtaposed colours, just as one must suppose an invisible magnitude, so must one suppose an imperceptible moment of time in order to explain the fact that the movements issue imperceptibly, and because they are simultaneously visible, the impression is a single one. There is, however, no such necessity here, but the colour on the superficies, when unmoved, and when set in motion by its substrate, produces unlike motions in the medium. Consequently, it appears different, and neither white nor black, so that if an invisible magnitude is not possible, but every magnitude must be visible from a certain distance, so there must be here also a certain mixture of colours. In this way, one may suppose that in objects viewed from a distance, a certain common colour is seen, for that there is no invisible magnitude is a matter that must be investigated later. If a mixture of bodies takes place, then it is not merely in the way that some think, viz. By the juxtaposition of minimal parts which are imperceptible to our senses, but also in the form of a general mixture of the entire substance together, as explained in outline in our treatise on mixture. By the former method of composition, only those substances can be mixed which are capable of analysis into minimal parts, e.g. men, horses, or seeds. In the case of men, a man is the minimal part. In the case of horses, a horse. Consequently, in both instances, the mass is formed by juxtaposition of these minimal parts. We do not, however, speak of a man being mixed with a horse. whatever cannot be analysed into minimal homogeneous parts is incapable of mixture in this sense, but only in the sense of total mixture, which is what naturally takes place in most cases. In our treatise on mixture, we have already explained how this can take place. Where bodies are mixed, their colours must evidently be mixed also, and this is the principal cause of the multiplicity of colours, which is not explained by their being superposed or by their juxtaposition. It is not true that what is mixed has one colour when viewed nearby, and another when viewed at a distance, for it has one colour when viewed from all points. And colours will be manifold because of the possibility of manifold proportions being employed in mixtures, some of which will be based on numerical proportion, others on that of disproportionate mass. Further, the same thing may be said of mixed colours as was said of juxtaposed and superposed colours. The explanation of the fact that we have fixed and definite varieties of colours, flavours, and sounds will be given later. Chapter 4. We have now explained the meaning of colour and the cause of its multiplicity. We had already discussed the subject of sound and articulate speech in the treatise on the soul. Smell and flavour now remain to be discussed. Both these terms signify almost identical natural affections, only each of them is found in a different organ. The quality of flavours is more distinct to us than that of smells. The reason is that our sense of smell is inferior to the same sense in other animals, and is inferior to all our other senses, while we of all animals have the most accurate sense of touch, and taste is a sort of touch. Water in its own nature has no flavour, and yet it is necessary that water should contain within itself the varieties of flavours, which, owing to their infinitesimal character, are indiscernible, as Empedocles says, or else there must be in water some such matter as is the universal germ origin of flavours, and in this way all flavours are generated out of water. Different flavours from different parts, or again, supposing that water contains no qualitative differences, we must then find some other efficient cause of flavour, such as heat, or the influence of the sun. The error of the Empedoclean theory is very easy to detect, for we actually observe flavours undergoing change under the influence of heat, e.g. when we expose fruits to the sun by removing their pericarps, or by heating them before a fire. They do not acquire this new flavour by drawing it out of the water, but by undergoing a change in the removal of the pericarp itself. When fruits are dried and stored, they become in time, instead of sweet, pungent or bitter, or change their flavour variously, and when cooked, they acquire, so to speak, all sorts of flavours. So too, the theory that water is a panspermic matter is impossible, for we observe that out of one and the same thing, as out of the same foodstuff, different flavours are generated. There remains the theory that water, by undergoing some external influence, changes. It is plain that the phenomenon which we call flavour is not due to the potency of heat. For water is the thinnest of all liquids, subtler than oil itself. Oil, however, is more expansile than water because of its viscous character, water being non-cohesive. For this reason, it is harder to hold water in one's hand than it is to hold oil. Now, since water is the only liquid which, when heated, exhibits no denser consistency than before, we must evidently look elsewhere for the cause of flavour, for all flavours are more dense when heated. Heat is a contributing cause, not the sole one. Apparently, the flavours that are found in fruits have a prior existence in the earth. In the same spirit, many of the ancient physiologers say that water is like the soil through which it passes, and this is particularly evident in the case of salt waters, for salts are a form of soil. Also, water that has been filtered through bitter ashes acquires a bitter taste. Further, we often find springs that are bitter and others that are pungent, while others still have different flavours. The greatest variety of flavours is found, as one might suppose, amongst plants. It is the nature of moisture, as of other things, to be affected by its opposite, and its opposite is the dry. Consequently, it is affected by fire, which is by nature dry. Now heat is the peculiar property of fire, and the dry is the peculiar property of the earth, as was said in the treatise on the elements. Neither fire, nor earth, nor any other element, as such, acts or is acted upon. It is only in so far as each thing contains in itself the principle of opposition that it either acts or is acted upon. As, therefore, those who dissolve a colour or a flavour in water cause the water to absorb it, so nature acts upon the dry and earthy elements, and by filtering water through these elements, and stimulating them into activity by heat, it causes the moist element to acquire a certain quality. This condition, which is wrought in moisture by means of the above-mentioned dry element, is flavour, and it consists in the conversion of a potential taste into an actual one. For the sense organ, which is already in a condition of potentiality, passes over into a condition of actuality. The process of sensation does not resemble learning so much as it resembles contemplation. That flavours do not attach to everything dry, but only to the dry that is nutritive, either as a positive or negative condition, one may conclude from the fact that the dry is not found apart from the moist, nor the moist apart from the dry. Neither one when taken alone is foodstuff for living creatures, but only when combined. In animal food it is the tactual elements which effect growth and decay, and it is by virtue of the warmth or cold in the assimilated food that these phenomena are produced. For these are the properties that cause growth and decay. The administered food nourishes in so far as it is gustable, for everything is nourished by means of the sweet, whether pure or mixed. This subject must be more definitely treated in the work On Generation. For the present we only touch upon it so far as necessary. Heat disposes to growth and brings food into a prepared condition. It absorbs what is light and rejects the salt and bitter because of their heaviness. What external heat effects in external bodies is also produced by internal heat in animals and plants. Nourishment, then, is caused by the sweet. The other flavours are mingled in food in the same way as the bitter and pungent, i.e. to serve as a relish. This is for the purpose of counterbalance, and because the sweet is over-nutritive and swims on the stomach. As colours are a combination of white and black, so flavours are derived from sweet and bitter. They depend severally on a proportion of more or less, on a proportion of mixture and motion, either numerically expressible or indeterminate. Those mixtures, however, which produce pleasure are numerically expressible. The oily flavour is to be classed with the sweet. The salt and bitter are closely allied, while the sour, pungent, astringent, and acid are intermediary. And so the varieties of flavours and colours are pretty nearly the same in number, for there are 6 of each, if one regards, as is reasonable, the grey as a sort of black. We have then to include yellow in white, just as we referred the oily flavour to the sweet, while crimson, sea purple, green, and blue are intermediary between white and black, and all other shades are combinations of these. As black is privation of the white in a diaphanous medium, so the salt and bitter are privation of the sweet in a nutritive moist substance. Consequently, the ashes of anything that has been burnt are bitter, for the potable element has been consumed. Democritus and most of the physiologers who treat the subject of sensation make the most remarkable blunder, for they resolve all sensible objects into the tangible. If indeed this is correct, each of the senses becomes evidently a sense of touch. It is not difficult to see that this is impossible. Further, they treat the common functions of all the senses as special functions. For the perception of magnitude, figure, roughness, smoothness, and sharpness and bluntness in solid bodies is the common function of all the senses, and if not of all, then at least the common function of sight and touch. It is in these perceptions, therefore, that the senses are subject to error, but they are not subject to error in their special sensations, e.g. sight is not fallible regarding colour, nor hearing regarding sound. Again, these physiologers refer the special functions to the general, as Democritus does with white and black, the latter of which he identifies with the rough, and the former with the smooth. And he reduces flavour to atomic forms. And yet it is either not the function of any sense to discern common properties, or else this power belongs to the eye more than to any other organ. If, however, this power falls rather to the lot of taste, it is at any rate the function of the most delicate sense to discriminate the slightest distinctions, each after its kind, so that taste would have to discriminate common properties better than any other sense, and be the most discerning judge of atomic figures. Further, all sensible objects contain the principle of opposition, e.g. in colour, black is the opposite of white, and in flavour, bitter is the opposite of sweet. But one figure does not appear to be the opposite of another figure, for to what sort of polygon would a circle be opposed? Further, the atomic figures being infinite in number, it necessarily follows that flavours are also infinite in number. For what is the explanation of the fact that one flavour produces a sensation and another flavour does not produce it? We have now treated the subject of the gustable and flavour. The other aspects of flavour receive their proper consideration in the treatise On the Physiology of Plants. End of chapter 4. Recording in memory of Mitchell Edwards.